In this video, we're going to take a final look at some of our reactions of the reactivity series, and we're going to look at the reactions with acid. Now, just before we do that, let's do a little reminder of what we've seen in the last couple of lessons. In the last couple of lessons, we've been reacting metals with water, and as we said before, water can be thought of as hydrogen oxide. So if you think of H2O, as most of you are familiar with the formula being, that's hydrogen joined to oxygen. So we call it hydrogen oxide. And when it comes to writing word equations, that made it nice and easy. Do you remember the things that reacted with water were more reactive than hydrogen? So they were stealing oxygen away from hydrogen. So things like, whenever we looked at the reaction of magnesium with steam, water, what we had written down was the word equation magnesium plus hydrogen oxide gave us magnesium oxide plus hydrogen. So what have we seen with the reactions with water? Well, you remember we've seen sodium. It's very reactive. Remember, that was a little speck of metal that we dropped onto water. It melts, it goes over the surface and so on. So that means sodium is more reactive than hydrogen. Whenever it's reacting, it's stealing the oxygen away from hydrogen. So sodium is more reactive than hydrogen. Potassium, we saw, was even more reactive. Remember, it went on fire. Whenever we put it onto cold water, it burst into flames and we got a bit of a fire with that. And that was the hydrogen being given off, and the reaction was so hot it was actually setting the hydrogen on fire. So potassium can also steal oxygen away from hydrogen. Potassium plus hydrogen oxide would give us potassium oxide plus hydrogen. Calcium, that was a new metal that we introduced, and it was a little lump. It sunk to the bottom, and it reacted quite well with water. Not just as good as sodium or potassium, but definitely better than magnesium. When we put magnesium in, do you remember, it hardly reacted at all with cold water, and therefore calcium was much more reactive. So we fit calcium above magnesium, but less reactive than sodium. And they're all more reactive than hydrogen because calcium reacts with water, so it would be calcium plus hydrogen oxide, giving us calcium oxide plus hydrogen. Magnesium, as we said, was very slow with cold water, but then in our last video we saw that magnesium reacted really well with steam. It caught fire when you put steam onto it, and it reacted really quickly with it. So magnesium, although it's less reactive than calcium, it's more reactive than hydrogen. So we're starting to put it in between those two in the reactivity series. Then we had iron and zinc, and they just about react with cold water, just very slight reactions, just with cold water, not very much at all. But they did both react with steam. When we put the powdered metal and we put steam over them, those definitely react with it. So again, iron and zinc are more reactive than hydrogen. They're be able to react with steam, so they must be more reactive than hydrogen. And then finally, copper. And whatever we did with copper, we put into cold water, it doesn't react. Put into steam, it doesn't react. And that's very useful as far as we're concerned, because our water pipes, hot water system, cold water system, are all made of copper. And we don't want our copper reacting with hydrogen oxide or water. We don't want that to happen, and it doesn't. So that's why we make cold water systems and hot water systems out of using copper pipes and copper implements and so on. Okay, so we're going to now put in our final reactivity series. This is the reactivity series with all of the metals listed. So let's put the ones that we've been familiar with. So in the first few videos, or the first few things we did in this, remember we saw sodium's very reactive, magnesium a little bit underneath that, zinc and iron underneath that, and then we had also done some reactions where we put carbon on, so we've carbon there, and then we've copper down towards the bottom. Now, look at the metals over on the right hand side. So silver and gold, first of all. Now, think of what we use silver and gold for. Well, that's right, we use it for things like jewellery, so things like rings and things like that. And you don't worry too much if you've got a silver ring or a gold ring and you go to do the washing up or you go to wash your hands, you don't worry about those reacting suddenly with the water, and they don't. So that would indicate that silver and gold don't react with water. And in fact, why we use it for jewellery is because they're so unreactive, they don't tarnish, they don't react readily. So we're going to put those at the bottom. And our bottom three metals are usually in that order: copper, silver is a little bit less reactive than copper, and gold is less reactive again. So they're the bottom three metals. Now, what about the one that goes to the top? Yeah, potassium. It's the one that reacted really well with water, catches fire, and it's actually even slightly more reactive than sodium. So therefore, that's the one they're going to put at the top. And then calcium. Now, do you remember where calcium fitted in? Well, calcium, remember, was less reactive than sodium, but a bit more reactive than magnesium. So yeah, we're going to put calcium in here. And then finally, hydrogen. Well, if you look at it, iron, zinc, magnesium, calcium, sodium, potassium, all of these have reacted with either cold water or with steam, but copper didn't. So hydrogen fits in there. It is more reactive than copper, so copper can't steal anything away from it, so it won't react with it, and it's less reactive than those. So that now is our final reactivity series. And one of the things I'd like you to do is to try and learn that reactivity series, know that order of metals. Because you're going to see that if you know that order of metals, you can actually write lots and lots of equations, and you don't have to remember lots of equations, you can work them out. So we're going to show that in the next slide. So look at all these questions. So we've got about 7 or 8 different questions there. And really, if you know the reactivity series, and you understand that things high up the reactivity series can steal from those lower down, you've no learning to do other than know the reactivity series, and you're going to be able to answer these questions. So let's put the reactivity series up. So there we are. There's potassium, sodium, right down to silver and gold. Now, let's see if we can predict the products of these reactions. So what if you had iron with copper oxide? Well, if you look at the reactivity series, iron is higher than copper, so it can steal away. So you think, what are we going to put in there? Iron plus copper oxide would give us? Correct. Iron oxide plus copper. So the iron will have stolen away from the copper. Now look at the next one. So the next one we've got is silver and copper oxide. Now if we look at those, copper is there, silver is there. So can silver steal away from copper? No. So therefore, that can't react. No reaction. So those two substances wouldn't react. And you've never seen that reaction before. I don't think I've even seen anybody attempt that reaction, but it doesn't work. It doesn't have a reaction. And we've worked it out from the reactivity series. What about the next one? Magnesium plus hydrogen oxide. Well, there's water. Well, again, if you think of the reactivity series, magnesium is higher than hydrogen. So yes, it will steal away. So magnesium plus hydrogen oxide would give us magnesium oxide plus hydrogen. Okay, it doesn't matter which order you put them in, whether you put the hydrogen first or the magnesium oxide first, as long as you get the two substances correct. And the last one, calcium and iron oxide. Now again, that's one that you haven't come across before. So let's go to the reactivity series. Iron is down here, calcium is up here. So yes, it could steal away. So then that would become calcium oxide plus iron. So that shows us that if we know that reactivity series, if we've got that reactivity series in front of us, then we can write out and work out those equations. Now, even if we come across things we've never seen before, so look at this. So we know that metals can steal oxygen, but they can also steal other things that are attached to them. And even if it's things you've never heard of. Now, these are things, compounds, that we will use over in the coming years in chemistry, and some of these we have used a little bit before. So copper sulfate, for example, is that blue solid that we've made crystals and solutions out of at different stages, and there's copper sulfate. Now, it's got copper joined to sulfate, and in the same way that metals can steal oxygen, they can also steal sulfate. So in a moment we'll work out what the product of that reaction is. And then there's one zinc and iron nitrate. So again, this is iron attached to nitrate, and metals can steal away nitrate in the same way that they steal away oxygen. So let's work out these ones. So it says, try to predict the reactions even though you've little knowledge of the compounds involved. So what about this one? Magnesium plus copper sulfate. Well, magnesium's above copper, so it can steal away. So what do you think that'll turn into? Yeah, so the magnesium will basically steal away from the copper, so that'll leave copper by itself, and then the magnesium will have taken the sulfate, so it'll have turned into magnesium sulfate. So magnesium plus copper sulfate gives you copper plus magnesium sulfate. The magnesium has stolen it away. This one, zinc and iron nitrate, so there's zinc and iron nitrate. So again, look at the reactivity series. So zinc's here, higher than iron, so it can steal away. So what we'll be left with is iron by itself, and the zinc will have stolen the nitrate and become zinc nitrate. And finally, copper and sodium sulfate. Well, copper is down here, sodium's way up there, so no, it's never going to steal away from it, so that one can't react, so no reaction. So using the reactivity series, you can see how you can apply that knowledge, or if you know this, if you know the series that we've got here, and you know that things high up can steal from those down, you can work out literally hundreds of reactions, all right, without having to learn lots of those. Okay, you can even get situations like this. So what could be used to steal oxygen from sodium oxide? Well, if you look at it, sodium's here. So where would we look for something that would steal away from it? That's right, up above it. So the only thing that could steal oxygen away from sodium oxide would be potassium. So the answer is potassium. So think of that. That's the way to use the reactivity series. And you're going to see that we're going to apply that in the lesson today with the reactions of metals with acids. Okay, so what we're going to show you today is the reactions of metals with one acid. We're going to reduce it down a little bit because we're showing this in video. And we're going to show the reaction with sulfuric acid. But you're going to see that, again, at the end of this, you're going to be able to write lots and lots of equations without having to learn an awful lot. Not even have to learn the equations. As long as you keep that idea that we've talked about in mind, that things, metals that are high up the reactivity series, can steal from those lower down. So the three acids that we use in the laboratory are hydrochloric acid, sulfuric acid, and nitric acid. Now, if you look at the formulas of them, hydrochloric acid's HCl. Now, we're not going to ask you to learn those, but why we put that formula in is, look at what it is. It's hydrogen attached to chlorine. And in the same way, when those two things are attached, metals that are higher than hydrogen should be able to steal these things away. So we can think of hydrochloric acid, if we think of its chemical name as hydrogen chloride. It's hydrogen joined to chlorine, and that's HCl, hydrochloric acid. So we will think of it in terms of words as hydrogen chloride. So every time that we're going to ask you to write an equation for this, although we call it hydrochloric acid, think in your head, it's hydrogen chloride. And anything that's higher than hydrogen can steal the chlorine away from it. The one that we'll show you is sulfuric acid. Now again, don't be worried about learning the formula. Look at the formula there, H2SO4. Now that SO4 bit, as we'll learn in chemistry, is called sulfate. So we think of this as being hydrogen attached to sulfate. So think of this as being hydrogen sulfate. And again, any metal that's higher than hydrogen will be able to steal the sulfate away from it. And then finally, nitric acid, HNO3. So again, it's hydrogen attached to this NO3 bit. And that NO3 bit is called, as we typo there, that's called nitrate. So think of HNO3 as hydrogen nitrate, right? So NO3 is called nitrate, so think of it as hydrogen nitrate, right? It's hydrogen nitrate. Okay, so to do these reactions, we're going to show you a little video, and the way that we're going to do it, we're basically going to do it in a test tube, and in one of the reactions, I'll demonstrate the test for a gas. Now, if you think of it, think of, say, hydrogen sulfate, right? Sulfuric acid, hydrogen sulfate. And a metal that reacts with it above hydrogen. So let's take, for example, say something like magnesium that's above hydrogen. Well, magnesium plus hydrogen sulfate, that should give us magnesium sulfate plus hydrogen. It's stealing away the hydrogen from the hydrogen sulfate. And so what we should be able to see is the gas hydrogen given off. Now, hydrogen is an explosive gas. This is one that you usually enjoy doing in the laboratory. And whenever we do this, we usually, to show that it is given off, we put a lit splint into a sample of the gas. And what it should do is explode or pop. Now, because only a small amount of it, it gives us a little pop, right? Usually quite a good one. But that's the test for it. So if we're going to test for hydrogen, we look for this pop. Okay, so we'll show you the reactions on video. So first of all, you'll see the setup for it. Now we're going to use sulfuric acid, and I was trying to hold the camera at the same time as do this, so it's a wee bit slow in putting some of the things in. Now what I've dropped into the acid there is a little lump of zinc, and once the camera gets focused you'll see there that the zinc as a lump doesn't really react very vigorously at all. And to show iron, I've got a little iron nail, and you'll see it's definitely an iron nail. Lots of nails are protected and so on. I had to get one that was a wee bit rusty. That's one that's definitely iron. And if you look at it, you'll see when it goes in, again, it doesn't appear to react very much at first. But if you look closely at both of them now, you'll see bubbles start to form over the surface. Now those bubbles are hydrogen. So that's showing that those metals are reacting with sulfuric acid. Now keep in mind, sulfuric acid we're going to call hydrogen sulfate. So zinc is reacting with hydrogen sulfate, and that's giving us zinc sulfate plus hydrogen. And those little bubbles are the hydrogen gas being given off. Now look at the iron. Can you see that it's reacting as well? Now it's not as fast. In fact, you can see the bubbles are being given off very, very slowly, but it does react. So zinc and iron are both above hydrogen, and they're reacting with hydrogen sulfate, sulfuric acid, hydrogen sulfate, and they're giving us the metal sulfate plus hydrogen. Okay, so the lump didn't react very, very quickly. So what I'm going to do is I'm going to set up 4 experiments just to compare the 4 metals that we've got there. So you'll see in the video we've got magnesium, we've got zinc, we've got iron, and we've got copper. And I'm going to drop the metals in. Now for the zinc and iron to react very well, we need to have a slightly faster reaction than we showed in the first one. So what we're going to do is we're going to drop a little bit of powder in, and that really shows in a good way a comparison of the reaction. So let's do magnesium first. So again, with a little bit of a reach there, we get the magnesium in, and this is just a little lump of magnesium, and look how fast that's reacting. So magnesium is way, way above hydrogen on the reactivity series. So magnesium and hydrogen sulfate, again once it focuses, becomes magnesium sulfate plus hydrogen. And you see lots and lots of bubbles being given off. Now you might have caught on there, I was putting a boiling tube over the top as we'd shown in the diagram. And in a moment you'll see the test for hydrogen. I got my daughter to hold the camera. She was a wee bit nervous, as you'll see whenever the test goes off. No need to be, but it's very difficult to do it. So there's the hydrogen, and you'll see that the camera jumps a little bit. It's quite a good reaction. You get quite a pop with it, and therefore that was hydrogen being given off. So there's a moment or two after the reaction finished. Look, the magnesium's all gone. Alright, so that's it, completely reacted. Now we'll show you zinc and iron. So here's some zinc going in. So we've dropped in the powder. And again, when we get in a little bit closer and it gets focused. And look how much faster it's reacting than it was as a lump. Now it's still not as good as the magnesium. We had to powder it. We're getting a few bubbles given off, but nowhere near as many as hydrogen. As with magnesium, nowhere near as much hydrogen as there was with magnesium. So it's a bit less reactive than magnesium, and in fact when I tried to pop it, it didn't work. So we're not getting enough hydrogen off quickly to get that good pop test. Here's a little bit of iron powder going into the next test tube, and hopefully you'll see after a short delay you get a slightly better reaction of the iron powder than we did with the iron nail, and you see some of the hydrogen being given off there. Again, nowhere as fast as zinc. So yeah, so that's going to be less reactive. So you can see we've got a reactivity series there, really, haven't we? Magnesium really fast, zinc a little bit slower, iron slower again. But they all react with the hydrogen sulfate, so they're stealing away from it. And then finally, there's a little piece of copper. And it doesn't matter whether we use a lump of copper or copper powder or anything else. Nothing. You can see there the copper isn't reacting at all. So there's the reactions taking place. That's the reactions with acid, hydrogen sulfate. So those that reacted with hydrogen sulfate must be less those that reacted with the hydrogen sulfate must be more reactive than hydrogen. Sorry, I'll go over that again. Okay, so those that reacted with hydrogen sulfate, they must be more reactive than the hydrogen is, and they've been stealing away from it. Those that didn't are less reactive than the hydrogen sulfate. So there's a little observation table, and you can put in your observations. Again, I'll go over it quickly, and you do this all at the end. So the zinc, you saw the fizzing was the main thing. It fizzed really, really quickly. The magnesium fizzed very, very quickly. It was the most vigorous of all. That little lump I dissolved and gave off lots and lots. Copper, no reaction. We're seeing that every time anything that's attached to hydrogen, we put copper into it, doesn't react because copper is less reactive than the hydrogen. And the iron fizzed slowly. So, to test for the hydrogen, we pop it with a lighted splint. So you saw the light go in there, and then it pops, and that's the sign that hydrogen has been given off. So the last thing to do is look over some of the trends, and again, if you want to pause the video and then try and answer these, and see if you could do the equations as well. And I'll go over these now in a moment or two. If you pause the video, I'll go over these in a moment, and then you can fill those in, and then try the equations that follow, okay? So, the metals in order of reactivity, well, the one that was most reactive there was magnesium. Then we had zinc, then we had iron, and then copper was the least reactive. And if you think of our reactivity series that we had at the start, yep, that trend matches perfectly. Why did we think that copper had no reaction with acids? Well, it's below hydrogen in the reactivity series. And then for all of these word equations, as you'll see here, keep thinking of hydrochloric acid as being hydrogen chloride. Think of sulfuric acid as hydrogen sulfate. So iron plus hydrochloric acid is iron plus hydrogen chloride, giving us iron chloride plus hydrogen. Zinc plus hydrochloric acid, so that's zinc plus hydrogen chloride. That'll give us zinc chloride plus hydrogen. And magnesium plus hydrochloric acid, well, that's magnesium plus hydrogen chloride, giving us magnesium chloride plus hydrogen. For sulfuric acid, think of sulfuric acid as hydrogen sulfate. So iron plus sulfuric acid gives us iron sulfate plus hydrogen. Zinc plus sulfuric acid, zinc sulfate plus hydrogen. Magnesium plus sulfuric acid, magnesium sulfate plus hydrogen. So these things then in chloride and sulfate we call salts, okay, and you're going to see that when we come to chemistry a little bit later on, what we always say is that every time an acid reacts with a metal, you get some sort of salt. So iron sulfate, zinc sulfate, magnesium sulfate, and then all those chlorides we saw earlier on, those are all salts. So acid plus metal gives salt plus hydrogen. Okay, so the final thing to do is you'll see a page of questions there. Now again, there looks like lots of equations. You don't have to learn them. Now the thing to remember, and look back over the video that we've done here, every time you've got sulfuric acid, think of it as hydrogen sulfate. Right? Every time you see hydrochloric acid, think of it as hydrogen chloride. And see if you can answer those questions. See if you can put down the products of those. And that's the only thing I want you to put back in. Again, if you can't print it off, all this on a file page or just on a page somewhere, and that's the only thing I want to see. I just want to see those equations sent in, and we'll be in touch soon.